It is 4 in the morning. The state of Pennsylvania is asleep. Inside Unit 2 of the 3 Mile Island nuclear plant, a single valve refuses to close. Nobody in the control room knows. The instruments say everything is fine. For the next 2 hours, a disaster assembles itself, piece by piece, in plain sight, completely undetected. One of the operators on duty that morning would later describe the first hour like this. It did not feel like a crisis. It felt like a confusing instrument test that would not end. They worked the problem the way they had been trained. That is the most important thing to understand about what happened next. This video is not about a freak accident. It is about 9 specific failures, mechanical, human, organizational, that investigators spent years documenting after the worst nuclear accident in American history. These are not theories, they are findings. Every one of them is verified. Stay with us. Because the closer you look at what happened on March 28, 1979, the more you realize this was not bad luck. This was a system failing exactly the way it was built to fail. Reason 1. The accident did not begin with an explosion or a fire. It began with a single mechanical component, a pilot-operated relief valve, known as a PORV, doing something it had done before, at other plants, without consequence. This time, consequences followed. At 4 in the morning, excess pressure built up in the reactor. The PORV opened automatically. That was exactly its job. The problem came seconds later, when pressure dropped and the valve was supposed to reseat and close. It did not. It stayed open. Coolant began draining out of the primary reactor system. The drain would continue, uninterrupted, for more than 2 hours. The record shows that this specific valve model had stuck open in multiple documented prior incidents at other nuclear facilities. That failure history was on file. Corrective action had never been mandated. The manufacturer knew. The NRC knew. Nothing moved. Think about what that means. A valve with a known failure pattern was installed in a nuclear reactor. Its track record was documented. And on March 28, 1979, it failed again. Inside a facility with more than 600,000 people living within 50 miles. The valve being open was not yet catastrophic. What made it catastrophic was what the control room believed was happening. That brings us to the second failure, a single light that told a false story. Reason 2. In the control room, there was an indicator for the PORV. When operators looked at it, the light told them the valve had received a signal to close. What the light did not, could not, tell them was whether the valve had actually obeyed that signal. The indicator was wired to the solenoid command, the electrical instructions sent to the valve. It was not wired to the valve stem itself. There was no sensor measuring physical position. Closed on the board meant only that the command had been issued. The valve had been draining coolant while that light sat there, calm and green, telling operators a story that was not true. Operators made every decision for the next 2 hours based on that indicator. They were not being reckless. They were doing what trained professionals do, reading their instruments and responding. The instrument was lying, and nobody had designed a way to catch it. The commission's conclusion was blunt. The indicator told operators that a signal had been sent to close the valve, not that the valve had closed. A design flaw this simple, this consequential, had never been flagged for correction. Operators believed the valve was shut. That belief would now drive every action they took, including the one that came closest to fully uncovering the reactor core. Reason 3. Somewhere in the first hour of the accident, the emergency core cooling system activated. Automatically. Correctly. It was doing its job. Within minutes, the operators turned it off. The ECCS is the last line of defense for a reactor core. It pumps high-pressure water in to maintain cooling when normal systems fail. Operators saw the pressurizer level rising and concluded, based on their training, that the system had too much water, a condition called going solid. They throttled the ECCS to prevent it. In doing so, they reduced the cooling that was keeping the core intact. This is where the story stops being about a rogue employee or a careless crew. The Rogovin report called this the most consequential operator action of the entire accident, and then immediately noted that the operators were following the logic their training had installed in them. They did not make a mistake. Their training made the mistake. By then, the evidence was already on file. Operator training had never prepared crews for multiple simultaneous failures. Nobody had ever shown these operators what a stuck-open PORV combined with a rising pressurizer level would look like together. They had never seen it. Nobody made them practice it. The ECCS being throttled left the core with reduced cooling. But why did the pressurizer show high when the system was actually draining? That answer is the technical heart of this entire disaster. Reason 4. Here is the central paradox of 3 Mile Island. The pressurizer level indicator was functioning perfectly. It was giving an accurate reading, and it was leading operators directly toward making the crisis worse. As coolant drained through the open valve, steam voids formed in the primary loop. Those voids pushed liquid water up into the pressurizer, causing its level gauge to read high. The instrument was measuring what was in the pressurizer. It was not measuring the state of the coolant in the reactor core. The core was uncovering. The pressurizer said full. Both things were simultaneously true. No operator in that room had ever been taught that a high pressurizer reading could coexist with an uncovering core. It was not in the training manuals. It was not in the simulator scenarios. The instrument was accurate. The operator's interpretation of it, the only interpretation they had been given, was wrong for this specific failure mode. The NRC's own post-accident analysis confirmed that under loss of coolant conditions, the pressurizer level indicator could produce readings that directly contradicted the actual state of the system. This was a known phenomenon in reactor physics. It had simply never made it into operator training. The technical paradox was real and survivable if someone, somewhere, had already encountered it and passed the lesson on. Someone had, 18 months earlier, and the lesson never arrived. Reason 5. In September 1977, 18 months before 3 Mile Island, an almost identical sequence of events unfolded at the Davis-Besse nuclear plant in Ohio. The PORV stuck open. Pressurizer levels rose. Operators throttled the ECCS. It was caught in time. And then engineers wrote down exactly what had happened and what it meant. Babcock and Wilcox analyzed the Davis-Besse event. Their engineers understood its implications. They produced internal memos, now known as the Kelly and Dunn memos, that specifically warned operators at B&W designed reactors were likely to misread rising pressurizer levels and disable emergency cooling as a result. The warning was technical, specific, and accurate. The memos were not transmitted with urgency. They did not reach Metropolitan Edison. They were not escalated to the NRC. A documented, named prior incident with a written warning predicting the exact failure mode that would later destroy Unit 2 sat in a filing cabinet for 18 months. The Kemeny Commission called the Davis-Besse incident a missed opportunity to prevent the accident. That is a precise phrase from an official government report. Not a near miss nobody could have predicted, a missed opportunity with names on the memos and dates on the filing. The warning existed. The lesson was written. The chain that would have delivered it to the operators at 3 Mile Island was never connected. That gap was not accidental. It was structural, and it was built, in part, by the training system that created it. Reason 6. Every licensed nuclear operator in the United States trained on a simulator. That simulator was designed to prepare them for emergencies. What the record shows after 3 Mile Island is that the simulator had been preparing them for a version of emergencies that did not include the ones most likely to kill them. Simulator training was built around scripted, single-point failure scenarios. One thing goes wrong, you respond, you resolve it. Nobody at the TMI simulator had ever run a scenario in which a stuck-open PORV and a rising pressurizer level occurred simultaneously and produced contradictory readings. That scenario had never been written into the curriculum. Operators had never practiced it and had no cognitive framework for diagnosing it. The post-accident review found the NRC's oversight of operator training programs was, in their words, quite limited. Training was designed and approved without anyone asking the most important question. What happens when two systems fail at the same time and the instruments point in opposite directions? There is a particular kind of danger in training that gives operators total confidence without total preparation. Crews at 3 Mile Island were certain they understood what was happening, certain they were following correct procedure. That certainty was built in a simulator that had never shown them this. Inadequate training filled the operators' heads with the wrong map. The control room then gave them too many signals to read it clearly. Over 100 alarms. No priority, no hierarchy, pure noise. Reason 7. Picture this. It is just after 4 in the morning. You are responsible for a nuclear reactor. In the space of a few minutes, over 100 alarms activate simultaneously. Every one looks identical. Every one sounds identical. The alarm system at 3 Mile Island Unit 2 had no priority hierarchy. A low-level administrative alert registered with the same visual and auditory signal as a critical safety warning. When the accident began, operators were immediately buried under a cascade of undifferentiated information. The Kemeny Commission stated plainly that the alarm sequence was, in their words, of little use. It was designed only to notify, not to help operators think. Control room design was approved under NRC standards that did not require human factors engineering review. Nobody had been required to ask whether a human being, a fatigued operator at 4 in the morning, could cognitively process 100 simultaneous identical alarms and extract the right signal. That question was never made mandatory before licensing. The accident prompted the NRC to commission an entirely new framework for human factors in control room design. New Reg 0700. That document became the standard for nuclear facilities across the country. It was written because of what happened on March 28, 1979. The standard came after the disaster, not before it. The operators were overwhelmed before they could think. The training had not prepared them. The instruments had misled them. And the institution responsible for catching all of this had spent years looking in the wrong direction. Reason 8. The Nuclear Regulatory Commission exists for one reason: to prevent exactly what happened at 3 Mile Island. The Presidential Commission found that the NRC had been doing a different job instead. The NRC had built a regulatory culture around licensing compliance, verifying that utilities followed documented procedures and passed formal inspections. What it had not built was a system for capturing lessons from real-world incidents across the industry and pushing those lessons back as mandatory corrective action. The Davis-Besse warning of 1977 never became a required safety bulletin. The operator training gap was never flagged. The PORV failure pattern was on file. Nothing moved. The Kemeny Commission's conclusion was pointed. The NRC was so imbued with the licensing and regulatory mentality that it had not been sufficiently concerned with overall safety. That is not an accusation. It is a documented finding from a presidential commission. The regulator had optimized for the wrong output. The accident forced the creation of an entirely new institution, the Institute of Nuclear Power Operations, founded in late 1979, specifically to fill the gap the NRC had left. An industry-wide safety body had to be invented from scratch because the regulatory structure had not been doing the job. The NRC had the authority to close every gap in this list before March 28, 1979. It did not. And the company operating the reactor had been sending the same message through its own internal culture for years. Reason 9. Behind every procedure, every training program, and every alarm system at 3 Mile Island was a company called Metropolitan Edison. The Rogovin report spent considerable time on what kind of company it was. Metropolitan Edison had not built the organizational culture, the internal reporting systems, or the emergency response procedures that a facility of this scale required. When the accident began, communications to the NRC and Pennsylvania state authorities were delayed. Information provided was incomplete. Some of it was inaccurate. The Rogovin report described the utility's response in the hours following the accident as reflecting a tendency toward reassurance over accuracy. This is a finding about priorities. When an organization consistently places operational continuity ahead of rigorous safety culture, it does not produce a single catastrophic decision. It produces a decade of small ones. Procedures slightly below standard. Training slightly below sufficient. Report slightly below transparent. Each small gap invisible on its own. Together they form the shape of a disaster. The NRC's post-accident review, NUREG 0654, used 3 Mile Island directly as the evidence base for mandating reform of operator emergency preparedness standards across the entire industry. Metropolitan Edison's failures were serious enough to rewrite national requirements. 9 reasons, each one real, each one documented, and not one of them was inevitable. Every single failure on this list had a specific moment, a specific decision, a specific document where it could have been stopped. Look at all 9 reasons together, and the same structure appears every time. A technical flaw existed and was known. A warning was generated and was filed. A training gap was identified and was not closed. A regulatory requirement was overdue and was not enforced. And a company was operating a nuclear reactor with a safety culture that was not equal to the risk. 3 Mile Island is not unique in this structure. Chernobyl follows it. The Challenger disaster follows it. The Banqiao Dam collapse follows it. The Beirut port explosion follows it. Across industries, across countries, across decades, disasters that are called sudden are almost always the final event in a chain assembled slowly, over years, by people who either did not look, did not act, or did not believe it could happen to them. The Kemeny Commission wrote that the fundamental problems at 3 Mile Island were people-related, not reactor-related, not technology-related. The machines behaved exactly as physics said they would. It was the systems built by people, training systems, regulatory systems, communication systems, safety cultures, that failed first. Disasters are not built in an instant. They are built over time, by accumulation, until one morning at 4 a.m., a valve sticks open, and everything that was already broken begins to matter. 3 Mile Island did not result in mass casualties. By the measurement of physical harm, it was contained. By the measurement of what it revealed, about the gap between the safety systems people believed existed and the ones that actually did, it was one of the most instructive events in the history of industrial risk management. 9 reasons, all documented, all preventable, all on file in some form before March 28, 1979. Disasters are built over time. That is not a metaphor, it is a finding.